Hi students, this is Mr. Yao. Today we're going to talk about 9.13, where we will practice more on the trig identities. Let's start with two examples. Number one, when you look at that question as secant and tangent, I kind of don't know where to start. And that's why I gave you guys the helpful tips. The second bullet point said if you don't know where to start or if you're stuck, you can always try to rewrite everything into sine and cosine. So let's actually try that. That's secant squared, which is 1 over cosine squared. So I'm just going to rewrite into cosine squared, 1 over cosine squared. Tangent is sine over cosine. Because it's squared, just square the top and the bottom. So that's the left-hand side. Because that is more complicated, we start there. Now you have fractions. And the other thing I mentioned in helpful tips is you gotta start having some intuition about how to work with fractions. And these are the same as just number fractions. They have the same denominator, so cosine squared on the bottom. As for the top is 1 minus sine squared. Right there, you have 1 minus sine squared. If you actually recall, we have learned sine squared plus cosine squared equals 1. I'm going to write it on the top. Sine squared plus cosine squared. If I actually move sine squared on the other side, cosine squared is 1 minus sine squared. So that means I can rewrite 1 minus sine squared as cosine theta squared. The whole thing becomes cosine theta squared over cosine theta squared, which is 1, and that is the right-hand side. So we got it right. If you can't realize that, at least you should know that 1 can be replaced as sine theta squared plus cosine theta squared. So you can replace this and get rid of the sine squared. You can still leave cosine squared on the top. That's number one. Number two is actually going to be very similar. We're still going to rewrite everything. So the left-hand side, cosecant is 1 over sine squared, and cotangent is cosine squared over sine squared. Now we see the common denominator is sine squared. The top is 1 minus cosine squared. So we have, in that case, if you look at the same equation, I this time subtract cosine on both sides. So I got that's got to be sine squared. Sine squared over sine squared is 1, which is our right-hand side. So we got it right. That's number two. And these two are actually the two more Pythagorean identities. We have this one, sine squared plus theta cosine squared equals 1. That's the first one. But we also have two more, and here they are. The other two, 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. So you see the tangent and the cotangent are being added. Then there's the other one, the secant and the cosecant. But of course, we are not always going to see these in this format, which is why here are some common rewrites that we may see. For the first one, we can actually subtract sine squared on both sides, and then we got just cosine squared left. Or you can subtract cosine squared on both sides, and you just got sine squared left. So when you see a question, you may not always see sine squared plus cosine squared. You may actually see something like this, 1 minus cosine squared, and you can replace that with sine squared as well. But do you have to memorize these? Of course not. If you don't, you can always just rewrite 1 as the left side, then do a little bit of subtraction. It takes a little bit more work, but you don't have to memorize all of these. But the more you practice, the more you will realize, well, you can see all of these over and over again, then you will kind of have an intuition about them. For the second one, I can rewrite it like this. I can subtract the tangent theta on both sides, so I got this. Or I can subtract the 1 on both sides, then I got the third one. The third identity, I can subtract cotangent on both sides, or I can subtract 1 on both sides, and these are the other two versions of rewrites. And since we just proved the two other identities from the first one, kind of basically know the first one is going to be the most important one. Even if you don't remember the other two, you can still use the first one to actually solve these identity problems. Now let's have a look at more examples. Number 3. I have sine, tangent, cosine, so I'm just going to rewrite everything. So my left-hand side is going to be sine times sine over cosine plus cosine. That is multiplication, so I have sine theta squared, because that's just basically over 1. So I can have sine theta squared over cosine theta plus cosine theta. You can also treat that as over 1. And next, I'm going to have common denominator. Common denominator in this case between cosine and 1 is going to be cosine. So I need to change that by multiplying by a cosine on the top and on the bottom. And if you don't know, this is the same as if you have, say, like 5 over 1 times by 3, the top and bottom is the same idea. Now we have cosine theta as the common denominator. As for the top, I will have sine squared plus cosine squared. And you should note it, sine squared plus cosine squared is 1. So I have 1 over cosine. 1 over cosine is secant, which is my right-hand side. It means I got it right. That's number 3. Number 4, I'll rewrite tangent and cotangent. That's got to be sine, so left-hand side equals. And you might be wondering, well, the left-hand side have 2 things, the right-hand side also have 2 things. So does that mean they're the same difficulty level, so I can start either side? Technically, yes. However, because multiplication, sometimes you can cancel things, we still treat addition and subtraction to be more complicated. That's why I'm starting from the left side. That's sine over cosine plus cosine over sine. And if you're like, I have no idea how to deal with that kind of fraction, well, then let's start with some numbers. Let's say you have something like that, which is very similar. In this case, your 5 is your sine theta, and your 3 is your cosine, and then the other fraction is flipped. As you can see, the common denominator in this case will be 15, and we're going to multiply that by 5, multiply that by 5, multiply this by 3, by 3. This is the same idea. We multiply the bottom to have the common denominator, which is cosine theta sine theta. But because that's the common denominator, in order to get there, I need to multiply this one by sine theta and the top and on the top and the bottom. And I need to multiply cosine theta on the second one, on the top and on the bottom. So it becomes sine theta squared on the top plus cosine theta squared. That's cosine theta squared, that's sine theta squared. Now I have both squared adding together, that's got to be a 1 on the top, the bottom is cosine theta, sine theta, and it's actually being multiplied together. Next, 1 over cosine is secant, and 1 over sine is cosecant. That happens to be the right-hand side, so we are done. That's number 4. Number 5. This is where things will actually get complicated, but let's still start with the same thing. Secant, left-hand side, secant is 1 over cosine, and the bottom is just a cosine. Something to emphasize on, they don't just cancel with each other, because this is on the bottom of the fraction. This for the bottom is actually on the top of a fraction, because you can put it over 1. So they don't just cancel. I'm going to rewrite the second part, which is minus sine over cosine, whole thing over cosine over sine. If you actually want to do what we did before, you may need to have the same denominator or the same numerator so that you can just cancel them out. However, in this question, none of them is like that. So if you recall, when we did, say, like 5 over 3 over 7 over 4, let's say that was the question. We're not always dealing with just in that format. Instead, we can think it as 5 over 3 divided by 7 over 4, which a lot of time we multiply by reciprocal of the second number. That's how it changes. We can do the same thing for this one. Top is the first fraction, so 1 over cosine, and it's dividing by this cosine theta over 1, so I'm going to flip it, so I have the reciprocal, so times 1 over cosine. For the second part, I'm going to do the same thing, keep the top, so sine theta over cosine theta. For the bottom, I'm going to flip, so I'm going to multiply instead by a sine theta over cosine theta. Now that looks slightly better, so I can start putting things together. 1 over cosine theta squared minus sine theta squared over cosine theta squared. Then you will notice they actually have the same denominator, so it's got to be that common denominator on the bottom. As for the top, 1 minus sine theta squared. That's going to become, again, 1 minus sine theta, you should notice that's going to be cosine theta squared over cosine theta squared, which is 1. That is the right-hand side, so we got it right. That's number 5. Next, number 6. This is where you may see, oh, the left-hand side and the right-hand side seems equally complicated, but the left-hand side has a higher power, so I'm going to start from the left. And if you recall, when we first learned about factoring, we had dealt with some difference of perfect squares. That is going to be one parenthesis being added, another parenthesis being subtracted. So in this case, 2 to the 4th power is a perfect square. That is also a perfect square. So I'm going to actually rewrite the left-hand side. That's going to become cosecant squared minus cotangent squared times cosecant squared plus cotangent squared. Now you might be wondering, why is it squared? Why is it not just a regular? Well, because it was 4th power. The square root of 4th power is squared. Next, if you actually recall, if you actually have a look at all the identities we have written down, even including the rewrites, it's right here. There's one that involves cosecant square and cotangent square. They subtract each other, actually gets you a 1. So in this case, the second part the first part can actually be replaced as a 1 times cosecant squared plus cotangent squared, which is just cosecant squared plus cotangent squared. That is our right-hand side. We're done. That is number 6. Number 7. Something to emphasize on is this square. When we square things, we have to write it twice and then do distribution. We can't just actually put that square inside and treat it that way. So a plus b squared is the same as a plus b times a plus b. So we need to actually distribute to get the final answer, which is going to be a squared, first two, and then ab, and then another ab, or ba, they're the same, and plus b squared. So that's what we should get. Now for this question, I'm going to follow the same thing. Basically, my a is my sine, my b is my cosine. So I would have sine theta squared plus cosine theta squared plus sine theta cosine theta plus cosine theta sine theta, which they are actually the same. And that's the first parenthesis. As for the second parenthesis, you have sine theta squared plus cosine theta squared, then minus sine theta cosine theta, then minus another cosine theta sine theta. I have opened all the parentheses. You're like, well, that's very complicated. I don't know how to deal with that. If you actually look carefully, I have a plus sine theta cosine theta. They cancel. Another plus cosine theta sine theta. They also cancel. So all I have left are these two parts. And now you may notice sine theta squared is plus cosine theta squared is actually a 1. And then the second one, that's also sine theta squared plus cosine theta squared. That's another one, which is 2. And that is our right-hand side. And we are done. That's number 7. Number 8. For this question, you can totally realize secant squared minus 1 is actually 10. So that's going to become tangent squared. And then you can deal with that question like that. However, I'm going to offer a different way. For that question, there are many different ways. There are like 4 different ways. I'm going to do something slightly different. Let's pretend you actually don't know secant squared minus 1 is tangent. Let's pretend you just forgot about that. The only thing you know are just like some rewriting. Then let's rewrite. Secant squared is 1 over cosine squared. 1 over cosine theta squared. And then I have 1 over cosine theta squared, again, minus 1. So this time, I'm going to keep the top. At the bottom, I'm going to have common denominator. Because this is a 1, so I'm going to have a 1. Common denominator is going to be cosine squared, so I'm going to need to multiply both the top and the bottom by cosine squared. Common denominator is cosine squared. On the top is 1 minus cosine squared. Now see I have a fraction on the top and a fraction on the bottom. I can multiply by an extra cosine theta squared. to get rid of both the denominator on the top and the denominator on the bottom. So the whole thing, I have a 1 on the top. On the bottom, I just have 1 minus cosine theta squared. And what is 1 minus cosine theta squared? That happens to be sine squared. So the next step, I have 1 over sine squared. Then the question is, what is 1 over sine? It happens to be cosecant. And that is the right-hand side. That's number 8. Number 9. Whew, that's pretty rough. I don't know where to start, so same thing. I'm going to start by rewriting everything. The left-hand side looks more complicated. That's where we will start. On the top is 1 over cosine theta times sine theta. On the bottom, sine theta over cosine theta plus cosine theta over sine theta. And that is the common thing we actually dealt with just a little bit ago. Find the common denominator on the bottom. That is the common denominator. So on the top, I keep everything. That's basically times that. So I have sine over cosine. That's on the top. As for the bottom, common denominator is cosine sine. That means this first fraction, I'm going to multiply everything by cosine. Second fraction, I'm going to multiply everything by, for the first fraction, I'm going to multiply everything by sine, because the bottom is missing a sign. For the second one, I'm going to multiply everything by cosine. So the first fraction now becomes sine squared on the top plus cosine squared on the top. So now I actually have sine theta over cosine theta, the whole thing over 1 over cosine theta sine theta. Then you look at the top fraction and the bottom fraction. They do share something. They share this extra cosine. So I actually want to get rid of things. That means I need to multiply both the top and the bottom by a bigger denominator. So I'm going to multiply everything by cosine first. That is gone. But I still have a sine on the bottom. So now I'm going to also multiply by an extra sine on the top and the bottom. So that is gone. Now I just have a 1 on the bottom. As for the top, I have a sine and a sine. So it's sine theta times sine theta over 1, which is sine theta squared. That is number 9, which is the right side. Number 10. Like I said before, we typically treat the addition or subtraction to be more complicated than the multiplication. So for this one, I'm going to start from the right-hand side first, which is tangent minus sine. So I'm going to rewrite sine squared over cosine squared, would have then minus sine squared. Or I can treat that as sine squared over 1. Common denominator, multiply both top and bottom by a cosine theta squared to get the common denominator. So I got cosine theta squared, top becomes sine theta squared, minus sine theta squared, cosine theta squared. Okay, and now you may see, this is something I want you to see. If you have x minus, say, xy, before we treat that, we actually factor. So we'll factor out the x because both parts have an x. And I have 1 minus y left. That is very similar to what we have right here. For both terms on the top, we have sine theta squared. So I'm going to factor that out. Sine theta squared. And I have 1 minus cosine theta squared. All over cosine theta squared. 1 minus cosine theta, that is sine theta. So I have 2 sine theta squares on the top. Next, if I just look at the first one, sine theta squared over cosine theta squared, that is tangent theta squared. Then I still have the second part, which is sine squared. That happens to be the left-hand side. We are done. That is everything for 9.13, trig identity. Thank you.